Okay, so before the video starts, I would like to inform you that I have prepared a coursebook containing my notes, Cambridge past paper questions, and my own solutions. You can find a link to this coursework in the description of this video. I will also be uploading my A2 A-level physics exclusively on Patreon, so let's have a look at my quantum physics coursework. Okay, so just like my coursework on polarization, we have my own notes, Cambridge past paper questions, and my own solutions, which are right here. So go to Patreon and you will have all the videos on A2 A-level physics. Okay, so polarization. Quite a daunting name, isn't it? Well, you've actually experienced its effects if you've ever been to the cinema to watch a movie. You see, the glasses that were given to you were in fact polarizers, as they can take this image and convert it into this image, which you obviously perceive it as 3D. The way these glasses function is by taking the photons that are emitted from the screen and restricting the vibrations to just one particular direction, and that cancels out all the noise to produce a 3D image. That's basically the concept behind polarization. So let's just dive right into the explanation behind how the magic behind the polarizer works, or functions if you will. Okay, so how do polarizers work? Imagine we have a lab and it's emitting photons of two different frequencies depicted by a vertical line and a horizontal line. Now, a polarizer is basically just a filter with a bunch of slits in it, and it will allow only the photons with the same shape and size to pass through, which is why these lucky dudes right here are able to pass through, whilst these sad guys here are stuck outside. So that's pretty much how polarizers work. Okay, let's start working some past paper questions. So question 1. In all of these polarizing questions, they will always provide you with a diagram illustrating a beam that's filtering through a polarizer to produce a polarized beam of light, which they like to call the transmitted light beam. So in this diagram we have a beam of intensity I node filtering through a polarizer to produce a beam, or a filtered beam of intensity I. Now I want you to pay attention to the direction of the slit. It's a vertical line. The first question wants us to find the angle at which we would need to rotate this polarizing filter in order to restrict the flow of light. To accomplish this, we would need to rotate it in such a way that the slit is a horizontal line, and that would be a 90 degrees rotation. So 90 degrees. Now, the second question, we have the same polarizer that has been rotated at an angle theta, and when we rotated it at this certain angle, we got the intensity ratio of I over I node is equal to 0.75. Now we are supposed to find the angle. So let's just write our formula here. I is equal to I node cos squared theta. Now we have cos squared theta and our ratio. Let's just write our ratio somewhere on the side here. I over I node is equal to 0.75. So cos squared theta is equal to 0.75. distributing the square on the other side would be square root 0.75. Theta would be the inverse of cos 0.75, which would produce 30 degrees. Okay, so now we're supposed to find a new ratio of amplitudes. Let's just return back to the former diagram here. We know that this beam right here is I node and this is I. But we also learned this formula here. I is directly proportional to a square, sorry. So we have I is proportional to a square. I node is proportional to a node square. So let's just write it here. I is directly proportional to a square. I over I node is equal to a over a node square. Sorry, this is supposed to be in. Okay, a node square. We also know the value for this ratio. Oh my god, that was such a terrible square. I'm just going to redo it. Okay, that's kind of better, I guess. So we know the value for this ratio, which is 0.75. So let's just write this here. A over a naught squared is equal to 0.75. We have the squares that are common, so we can just get them out to produce a over a naught square 75. And in order to find the ratio, we simply need to square root 0.75, and that would produce 0.866, which can be rounded off as 0.87. Okay, so we now shift to the second question. And as mentioned before, we have the same diagram of a beam of intensity I node filtering through some polarizer to produce a beam of intensity I. But in the question, we are supposed to find the ratio of amplitudes, which is basically the same question what we did here with some extra steps because, well, 3 marks. So let's just begin by writing our formula. I is equal to I node cos squared theta. I over I node theta. And theta is 20 degrees. So let's just chuckle that in. I over I node is equal to cos squared 20. We also know that I is directly proportional to a square, which means I over I node is proportional to a over a node square. So we can simply substitute this ratio with this ratio here. So a over a node square cos squared 20. And now we send the square this side, which will be square root cos 20. That should be given us 0.94. Done. Okay, so the second question wants us to find at what angle would we need to rotate this filter so that we would get the same intensity of light I. So we know that this is 70 degrees because, well, 90 minus 20 is 70. And then we would need to rotate it at another 70 degrees because this is going to be 20 to produce our beam of light again. 70 plus 70 is equal to 140. So basically when we rotate it at 140 degrees, the would look something like this. And that would allow the flow of light to be the same intensity as it is here. So that's pretty much it. Okay, so number 4, we have the same polarizing diagram. Find the ratio of I1 over I node. So I1 over I node cos squared theta. I1 over I node cos squared theta. Okay, I1 over I node is equal to cos squared 30, which should give us 0.75. 0.75. So for the second question, we are supposed to find the ratio between I2 and I1. And to do this, we need to subtract the angles because this is 90 degrees, whilst this angle has already been rotated 30, so we need to extract the 30 from the 90 because the beam of light that's entering the first filter has been rotated. Its amplitude has been rotated by 30 cos theta. So this is why we need to extract the 30 out of it. So new angle of theta is equal to 90 minus 30 is equal to 60. So I2 over I node is equal to cos squared 60, which is 0 to 5. Now, in order to find the I2 over I node, we need to multiply both answers. Okay, why? Because the beam of light is passing through polarizer P1 and P2. In mathematics, and stands for multiply. So we need to multiply both of the polarizing answers, both of the ratios. So 0.75 and 0.25. 0.75 multiplied by 0.25 is equal to 0.1875 is equal to 0.19. 0.19. That's your answer. If the question stated the beam of light is filtering through polarizer P1 or P2, then we would need to add the answer, but that doesn't make much sense now, does it? So it's the beam of light is passing through polarizer P1 and P2. So multiply. You just multiply them always and you get your answer. Okay. I hope this video was insightful, and I'd highly recommend going through my worksheet, working out all the questions by yourself. You have my answers. Everything's been done with little nuggets of explanation where need be. So have fun.